Hello and welcome to this episode of Math with Martinez. We are in our Algebra 2, Unit 3, where we are studying systems of linear equations and inequalities. And this is part 2 of our first learning objective video where we're looking at formulating and solving systems of two linear equations. We've already seen how to solve systems graphically, but what we're going to look at in this video is how to do so algebraically. And the first algebraic method that we're going to notice in this video is by substitution. So when you are solving by substitution, it's usually because your equations are not already in a nice graphing format, but one of them is ready, perhaps so that you can quickly substitute. So step number 1, you're going to solve either equation for a convenient variable and substitute it into the other equation. Notice here that y is already solved for. I'm going to take this expression and I'm going to substitute that in my other equation for y. I'm going to replace y with what it is equal to. So let's go ahead and show that here. That would be to have your original equation, which is 3x plus, but now the substituted value, which we'll always put in parentheses whenever you're substituting, and what it equals. That is step number 1. Then you're going to solve that resulting equation. All right, so what do we have? Let's rewrite it again. 3x plus x minus 8 equals negative 20. Because we're just adding, it's really the same thing as saying plus x minus 8 equals negative 20. Those terms that have x are on the same side, so we can combine those together to give us 4x minus 8 equals negative 20. Next, you want to always undo addition or subtraction first, so we'll add 8 on each side, add 8 on each side. Draw a vertical line here so that you can divide your work and not get it mixed up. That's going to give you 4x equals a negative 12. And then lastly, divide each side by 4. That gives you x equals negative 3. Now, you're going to take that value and substitute it into either one of the original equations to determine the value of the eliminated variable. We know x, so now we're trying to find y. That, the easiest equation would be the second equation to substitute into, right? Which one is easier to work with if you're going to plug in the value of x? Definitely that second one. So we're going to take and figure out our value for y. It's just our value that we found, negative 3. Again, let me kind of do this right here. This is our value of x, and so that's what's going right here, negative 3. And then subtract 8 from that. And so that means that our value for y is a negative 11. You're going to write the solution as an ordered pair. X value always comes first, and then your y value. And that, ladies and gentlemen, is solving by substitution. There you go. Let's look now at our second methodology. When you're solving algebraically, you can also use elimination. And elimination is a really good method to use when you kind of have this already stacked up setup. What do I mean by that? When your x's are both in a line, your y's are in a line, and your constants are in a line, in alignment with each other, creating a column kind of effect. When it's set up like this, there's often the option for you to use elimination. And so what are we trying to do here when we're using elimination? You're going to add the equations to eliminate one of your variables. Now, if the coefficients are opposites, then you're adding. But if your coefficients are exactly the same, then you're going to actually be subtracting your equations. And that's actually what we're going to do here for this one, because I'm noticing here my y's are the same. Do you see how those y values are the same? So what we're going to want to do is we're going to want to subtract these equations. Here's what that looks like. We're going to take x plus y equals -1, and then I'm going to subtract that entire second equation from it and figure out what that result is. Okay, so be really careful here because we're subtracting each of these terms. So if I take x minus 2 x's, that's going to give me a -1x. If I take y minus y, that will zero out. And if I take -1 minus 2, that's going to give me a -3. Then we're going to take that equation and solve what we've got there. So we've got -x equals -3. In order to solve, what I'm going to need to do here is divide each side by -1. That's going to give me x equals a +3. So that is my first value that I've found. I found the x value this time around. And we're going to substitute that into either of your original equations. I always try and choose the easier one. Let's see, which of the original is easier? I would say the first equation is a little bit easier. So that's going to be to take and plug in 3 and then add to that y, and it should equal -1. So what do I need to do on each side here? If I'm trying to solve, I'm going to need to subtract 3 on each side, and that's going to give us y equals -4. Now we're ready to write our equation as an ordered pair. We've got our x value, we've got our y value. So your solution is the ordered pair. X comes first, and then your y value. That is the point where these two lines, when graphed, would intersect one another. If you take that point and plug it into your original equation, it would make it true. Let me prove that to you. If you take your x value, if you look at that first equation, it's x plus y. So if I take my x, which was 3, and I add to it my y value of -4, it gives me the output of -1, which was the goal. And if you take and plug it into the second equation, 2 times your x value plus your y value gives you 2. So there you go, proof that that is the solution. Now sometimes your equations will look like this. They don't look really like easy and ready to graph, but they do look lined up and ready for elimination. But notice that neither of these are like the one before where it was just like the same, like y and y or y and -y. They're all a little bit different here. So when that happens, you may need to multiply one entire equation by a value, by a constant, in order to produce equations that have opposite coefficients. So looking at the first that I highlighted in red, if I wanted to have the red equations eliminate, there's nothing I can multiply 7 by to give me 5. I can't multiply 5 by something and get 7. So I really don't want to choose that one if I don't have to, because that would mean I'd have to come in here and multiply this whole equation by 5 and this whole one by like -7 to get my first equation to have a +35 and the second one to have a -35. I don't really want to have to do that much. But what I am noticing is I could take, let me bring and write this down. I could eliminate my y's a little bit more easily. If I take and multiply this second equation by a -3, check out what happens here. My first equation is going to stay exactly the same. But now my second equation is going to be a -15x, then a -6y, and a -3. Now that's going to work out nicely because check out what happens here. My 17 and my 5, those are going to combine and give me a negative 8x. But my y's are going to cancel out. So I have eliminated my variable of y. So now I have negative 8x equals negative 7. Okay. Now to finish solving that equation, I'm going to divide each side by the negative 8. Divide by negative 8. And that gives me x equals a positive 7 over 8. Now we're going to take and plug that back in to our original equation. One of the originals. It actually doesn't matter which one. I'll go ahead and multiply it into the... They're really both equally difficult, so I'm going to take it and plug it into the first one. And that will allow us to find our value for y now. So this is going to be one where you might want to grab your graphing calculator because we've got some fractions that we're going to need to multiply. I have 7 being multiplied with the fraction 7 over 8. I'm going to actually take that and express it as a fraction. I need it as a fraction. So that's 49 over 8 plus 6y equals negative 4. I need to subtract that 49 over 8 on each side. And that's going to give me, I need to take my negative 4 and subtract 49 over 8. And again, I want that as a fraction. So I have 6y equals negative 81 over 8. Then the last thing I'm going to do is take and divide by 6. Now, dividing by 6 is the same thing as multiplying by the reciprocal. So I could say multiply this side by 1 over 6 and multiply this side by 1 over 6. That's going to work a little bit better since we have a fraction, right? So I'm taking my previous answer, just go up and highlight it and press enter, and it'll copy it down. Then I'm going to multiply it by 1 over 6. And again, express that as a fraction. And we have negative 27 over 16. So our solution, the x value was 7 over 8 and negative 27 over 16. We would not have been able to determine that one graphically, right? So we see that algebraically would be the only way to solve this because this is not a nice ordered pair. We wouldn't be able to see that intersection if we just sketched it out. So the algebraic method really does come in handy, especially when your solutions are not nice integer values, which is probably more often than not. Guys, if you had any questions while watching this video, would you please take a moment and share those now? And until next time, stay fired up.